Yo, what's up everyone? Patrick here, welcome back. And in this video, what we got to do is use the intermediate value theorem to show that this equation here has a solution within this interval between x values 1 and 2. So if you remember from the lecture videos on the intermediate value theorem, the way I like to do this is I like to bring everything over to one side and create a function. So if this here has a solution at a certain x value, that's the same thing as at that same x value, this whole expression equaling 0. Right? At that x value, if this and this are equal, then that means this minus this is going to equal to 0 at that same x value. So what we can do is we can just label this for now as a function. I'm going to call it f of x here. Now, a couple of things to note here. Notice that f of x is continuous on 1 and 2, between x values 1 and 2. It's actually, in fact, continuous for all real numbers from negative infinity to positive infinity. Notice that there's no x value here that you can't plug in into this function, right? So you always got to make sure that in order to use the intermediate value theorem, you got to make sure that that function you're working with is continuous on the interval that you're working with. It doesn't have to be continuous for all real numbers like this function is, but it does have to be continuous for the interval you're working with. Now, what we want to do is figure out what's f of 1 going to be, and then what's f of 2 going to be. Let's see what the value of this function is going to be at those x values on the ends of the interval. So what we would end up having here is cos of pi, right? Pi times 1 is just pi, minus e times 2 sine of, notice that if we plug in 1 for x, we'll have 2 in the bracket, divided by 2, those cancel out. So here we would end up with sine of pi, like that. Now, what is cos of pi? What is sine of pi? So if you remember the graphs, let's do a little review here. This is the cos graph. So cos of pi, -1. Right, I'm actually going to continue it over here. I'll bring f of 2 in after. So this is going to be -1. And then we're going to be subtracting e to the power of 2. Now, what's sine of pi going to be? Sine of pi, notice, is just 0. At that x value of pi, the y value is 0. Right? So this here is going to end up being 0 times 2 is just 0. And so we would end up with -1 minus 1, which would give us -2. Okay, so f of 1 is equal to -2. Now, what's f of 2 going to be? What's the value of this function going to be at the x value on the end of that interval? So we would end up having cos of 2 pi minus e times 2 sine of, notice here we'd have 2 plus 1, which is 3 over 2. So we'd have 3 pi over 2, which is like 270 degrees if we convert it to degrees. So what's cos of 2 pi? Well, from this graph here, 2 pi is over here, right? So notice 2 pi is going to end up being 1, this point right here, minus, what's sine of 3 pi over 2? Well, 3 pi over 2 is over here, right? So notice that sine of 3 pi over 2, that's going to end up being -1. So we would have e, -1 times 2 is just -2, like that. So we'd end up having 1 minus e to the -2, which we can rewrite as 1 minus 1 over e to the 2, like that. Now let's pretend we're not using a calculator here. So notice 1 minus 1 over e to the 2. Notice that f of 1 is less than 0, and notice that this here is greater than 0, because notice that 1 over e to the power of 2, that's going to be less than 1, right? 1 divided by a larger number than 1 is going to be less than 1. This is like 1 over 2.7, etc., to the power 2. That's going to give us a number less than 1. So we're taking 1 and subtracting a number that's less than 1, which means that this overall number is going to be greater than 0. It's going to be positive here. So now notice that by the intermediate value theorem, notice that between these x values, this function has to equal 0 at some point. Okay, so let me kind of show this visually, and then we'll write a concluding statement. So for this function, I actually don't know how this function looks like, but what I do know for sure is that at an x value of 1, we're going to have a y value of -2, which is going to be down here. And I know that at an x value of 2, we're going to have some kind of positive y value. I don't know what the decimal of this is going to be, but it's going to be some kind of positive y value, so it's going to be here. And we also know that this function is continuous within that interval. So if it's continuous, it's got to go from this to this, so at some point it's got to cross the axis. At some point it's got to equal, this function has to equal 0. So it could equal 0 multiple times maybe it'll cross multiple times, maybe it'll just cross once, we don't know. But what we do know for sure is that there's going to be a solution within that interval. So what we can say, the concluding statement, now your prof may want a certain format for the concluding statement. I am not the best at making these, but the way I would make the concluding statement is I would say, since f of x is continuous on the interval 1 and 2, between x values 1 and 2, and f of 1 is less than 0, and f of 2 is greater than 0, then by the intermediate value theorem, there exists a number, let's call it C. There exists a number C where C is between 1 and 2, where C is between 1 and 2. Let me read this. Since fx is continuous on this interval and f of 1 is less than 0 and f of 2 is greater than 0, then by the intermediate value theorem, there exists a number C where C is between 1 and 2, where f of C is going to equal 0. Where it's going to equal a y value 0, where it's going to cross that axis at some point. Right? So because we showed this, number 1, that it was continuous on that interval we're working with, and because f of 1 was less than 0 below the x-axis, and f of 2 was above the x-axis, it's continuous below, above, then we know that there's a number, there's an x value in between 1 and 2. I said a number C between 1 and 2, where that function is going to equal 0, where that function is going to cross that x-axis.